Thank you so much for coming to our presentation. My name is Kazuya Saito. I am an SLA researcher from University College London, and here is
Adam Tierney. I'm from Birkbeck College, University of London.
He's a psychologist. Okay, so this is what we would like to do in our presentation. First of all, we would like to introduce the emerging idea of auditory processing as a key aptitude for second language learning. And then we would like to share our team's recent work on this topic, published in both SLA and psychology journals. And finally, Adam will take care of the latter half, providing us with his interpretation of what our findings actually mean to the bigger picture of human language learning, especially from the perspective of psychology, and he will give us the future directions that researchers, including us, should further pursue. So, over the past 50 years in the field of SLA, one major concern topic is what is the key to success? And one obvious answer is how much you have been practicing the second language. But research has also shown that experience-related factors cannot explain everything about the successful second language learning. For example, even if we have two identical second language learners with the exact same level of motivation and exact same age, and let's say they have practiced a target language the exact same way, spending exact same amount of time, but the outcomes of their second language proficiency learning will be most likely subject to the individual differences like that. So as of 2020, the hottest topics in SLA is what underlies such individual variation. So our research team is now proposing some new, relatively new conceptual framework for second language learning. Our message is very simple. That is having a good ear, auditory processing as academic term, is a root of language acquisition. So what is that auditory processing? In cognitive psychology, it's the perception ability to encode domain general dimensions of acoustic signals, such as duration, amplitude, or pitch, and higher frequencies, such as formants. And because it's a perception ability, it's considered to be a more basic, fundamental, and bottom-up processing ability. And in the field, it has been considered as obviously the gateway to spoken language, because it's the beginning of language learning and acquisition. If you have problems at this level, it would immediately affect your speech perception learning, and it will lead you to have more like phonological problems in the end. In the long run, you'll likely end up with the more global issues such as reading, listening, and speaking. And quite recently, Mueller et al. 2012, they have proposed that individual differences in auditory perception will also play a crucial role in even the post-pubertal second language acquisition. And our team has taken this message seriously and subjecting it to the thorough scrutiny of this topic in line with the latest SLA paradigm. So this is what we have been doing. We have recruited more than 200 Polish, Spanish, Chinese, Japanese, Vietnamese learners of English in both immersion settings, London, or classroom settings, Japanese EFL classrooms, Vietnamese EFL classrooms. And their biographical backgrounds are widely varied. The length of immersion, some of them have never been abroad. Others have been there for like 20 years. And what's in common among this population is that if they had any immersion experience, they must have come to the target language speaking country after the age of 17, meaning all of them were late bilinguals. Method. So we have been checking the second language proficiency from multiple angles. Phonology, vocabulary, grammar. We check the comprehension, production skills. And we have been inspecting the auditory processing abilities. I'll come back to this point in a minute. And then we have been surveying, interviewing their biographical backgrounds, such as length of residence in target language speaking environment, and also length of foreign language education, and age-related variables such as onset of immersion, onset of foreign language education. So one unique selling point of our research team is we have been approaching this goodness of ear auditory processing from different angles. We have been using a traditional method, behavioral measures. So we prepare a range of synthesized samples where we control the, one or two acoustic dimensions, and participants are asked to listen to them, and basically they're asked whether the sounds are different or not. For example, did you hear difference, or did you think that these sounds are same? Actually, these samples were different. We just manipulated the second format only. But this behavioral paradigm obviously requires participants to rely on the cognitive abilities, such as attention control. Therefore, we have been also approaching the auditory processing by using an EEG, so that we can see how your brain is reacting when you're being exposed to such sound samples. So with this method, we're able to see how brain waves replicating or simulating sound waves. Our analysis, basically, we have put all these variables, experience-related variables, as well as auditory processing variables, into multiple regression or mixed effect regression models, so that we can see which variables are relatively important for predicting the success, meaning outcomes of second language proficiency. And findings, basically, it really depends on where they are and how they have been studying second language English in this case. So when we focused on a group of experienced second language learners who have been in London at least 1 year and all the way up to 20 years, the findings show that the outcomes were primarily predicted by auditory processing profiles. In explicit auditory processing, they explained 40% of variances, and the experience came as a secondary predictor. What's really interesting is that when we shifted our attention to less experienced second language learners with the length of residence profile less than a year, then it is now the experience-related variables that primarily predicted the outcomes of their second language proficiency, and with auditory processing being as a secondary factor. And quite recently, we have begun to look at even foreign language learners who have never been abroad, learning English target language only through the grammar translation method and the contextualized training. And now, auditory processing does not even reach statistical significance. The outcomes were mainly predicted or solely predicted by experience-related variables. Therefore, our tentative summary is auditory processing can explain larger variances in second language acquisition when learners have received more naturalistic, contextually rich, meaningful input in immersive settings in a very similar way to the first language acquisition. In this case, as in L1 acquisition, auditory processing seem to play a stronger role in the outcomes of language learning. So now, it's now over to Adam.
Great, thanks, Kazuya. So I'm going to start off by just summarizing again what we learned, summarizing it just slightly differently from what Kazuya just said. So my one-sentence summary of all this work we've done is that we found that perception of single auditory dimensions is a good predictor of second language learning. But however, we found that's mainly the case in experienced second language learners. So in language learners who have already been immersed for a fairly long time in a second language learning environment. So next, what I'm going to talk about for the remainder of this talk is where we're planning to go next. So one of the most exciting stages of science for me is when you get a set of results, and now it enables you to ask questions you might not have even ever thought of before. And I'll be focusing on two questions in this talk. First, I'm going to ask why having a good ear might be important. We found this relationship between auditory processing and second language learning, but these seem fairly different things. So what actually is driving the link between them? And second, I'll be asking, this is a more practical question, but I'll be asking whether it might be possible to train people's ears to make them better at auditory processing, and what the consequences might be of doing that for possibly helping them learn languages. So let's start with this first question. Why does having a good ear improve second language speech perception? And this might at first seem like kind of a strange question to ask, because obviously speech is a kind of sound. So you might think, well, obviously, of course, if you're better at perceiving sound and speech is a kind of sound, then it makes sense that we would find this link. But what's surprising about this is that it goes against the research that's been previously published looking at adults understanding and speaking their native language. So in L1 speaking adults, there's actually no link between auditory perception and speech perception. So why then are we finding something different for second language learning? Why do we find this strong correlation between auditory perception and speech perception? And why is that relationship specific to people who have been immersed for at least a year? So that's what I'll be kind of trying to explore in this talk, and I'll come up with a hypothesis at the end that we'll be testing in future work. So in order to answer that question, though, or try to answer it, I need to first move on to a related question is, well, why wouldn't there be a relationship between auditory perception and L1 speech perception? Because that's sort of the, the strange finding which drives this question. And one possible answer is that in speech, linguistic features tend to be linked to many cues, or tend to be linked to information that's conveyed across many different auditory dimensions or channels at the same time. That's sort of an abstract statement. So I'll start with a specific example. So when people speak, there are cues in their speech which help convey the location of phrase boundaries. If you're not sure what a phrase boundary is, that basically means where the comma would be if you were reading the language. And so just to illustrate that, the sequence of words after John runs the race can be read out loud in two different ways. Which emphasize two different locations of phrase boundaries. So for example, I could say, after John runs the race, and in that case, the comma would be after runs. Or I could say, after John runs the race, and in that case, the comma will be after race. And there are a number of different acoustic sound cues that help you perceive that the phrase boundary is there. I'm going to focus on two main things here. First, the word just before the phrase boundary is a little longer, and also the word just before the phrase boundary features a large movement in pitch. This feature of redundancy in speech, so a given feature being conveyed by many cues, is very important. And the reason for that is that if a listener, for any reason, has trouble with one of those cues, they can just pay more attention to the rest and still extract the information they need. In other words, over time, as people learn language, eventually they can develop perceptual strategies that help them compensate for their perceptual combination of weaknesses and strengths. And so this might be able to explain why there's not a correlation between auditory perception skills and first language speech perception, because people have been able to develop these strategies to get around any problems with sound perception they might have. So briefly, I'm going to go over a specific example to illustrate this from my lab, a study that we conducted last year. So we looked at participants with a particular condition known as amnesia. And this is a difficulty perceiving pitch. Now, in English, pitch does convey a lot of useful information. So listeners can use pitch to detect whether a word is emphasized or a syllable is stressed, where a phrase boundary is. However, some people have a lot of difficulty perceiving pitch. This is called amnesia. And the interesting thing about it is that in these individuals, they don't have trouble with any other aspects of sound perception. It's very specific. Now, these people report no difficulties with speech perception or production in daily life in their first language. And this initially might seem like a paradox. On the one hand, they have trouble perceiving this very useful sound quality. On the other hand, it doesn't actually seem to matter. They have no difficulties in daily life. So why is that? Well, we decided to look to see if they might have developed these compensatory perceptual strategies. And the way we did this was by designing a paradigm in which we would present participants with phrases that were basically created so that they varied in their pitch patterns and their durational patterns to convey whether either a first word or second word of a phrase was emphasized. Either the word study would be emphasized or the word music would be emphasized. And we can independently vary these two cues. So we can create stimuli where they imply the same thing. So in this case, both cues imply that the word study is emphasized.
Dave likes to study music.
And on the other hand, we can create ambiguous stimuli where these two different dimensions suggest conflicting interpretations.
Dave likes to study music.
And then we can present each of these stimuli to participants many times, and we can just see which of these two things they perceive, and then we can see how they're integrating these two different sources of information to make this decision. And what we found is that the amusics, who again have pitch perception problems, that they didn't use pitch information as much. And you can see that in this categorization function in the top left. Here, this is showing how the change in categorization decision is relating to the change in the level of that cue in the stimulus. And here you can see that the change in pitch is not affecting their decision as much compared to the controls, and the opposite is true for duration. So amusics seem to have developed this compensatory strategy where they're actually not that affected by their perceptual problem. So we can then ask, well, why might that then not work for second language learning? Why is there this much stronger relationship between auditory processing and language learning? Well, one possibility is that developing the right perceptual strategies takes time, and it might be particularly difficult for second language learning. This is because different languages use sound in very different ways. The ways in which meaning is linked to sound differ a lot across basically any two languages. I'm going to focus here on one particularly dramatic distinction, which is between tone languages and non-tonal languages. Tone languages like Mandarin, in these languages, pitch is very important because it conveys word meaning. The meaning of a word can completely change depending on the way pitch changes during that word. However, in non-tonal languages like English, pitch is still somewhat important, but it plays a more secondary role, and you can get a lot of the same information by attending to other sound characteristics. So learning a new language requires learning new relationships between auditory dimensions like pitch and duration and linguistic meaning. You sort of need to throw out your old perceptual strategies and learn new ones. Another way to put this is that learning new perceptual strategies requires listeners to attend to auditory dimensions. And again, this is exactly what we're asking them to do when they take these auditory processing tests. So to examine in a little more detail whether this process of learning new perceptual strategies might be difficult and whether it really involves this attention to sound dimensions, we investigated perceptual strategies in participants from 3 different language backgrounds. So we looked at native Mandarin speakers, native English speakers, and native Spanish speakers. And we gave them a speech categorization test that's very similar to the one I already described when I talked about the Amnesia study. And we found that the Mandarin speakers, compared to the other 2 groups, when perceiving phrase boundaries in English, they used pitch to a much greater degree, and they made much less use of other sources of information, such as duration, when performing this categorization. So they had this perceptual strategy in which they overemphasized pitch and they underemphasized other sources of information. Now, to see if this is because they had a tendency to attend to pitch more than to other dimensions, we gave them a second test in which we actually asked them to pay attention to different things in speech. So we made a test in which there were 2 words, and one of the words was always higher in pitch than the other word, and one of the words was always louder. And we asked them to either listen to the pitch and say which was higher, or listen to the loudness and say which was louder. So on the left here, this is when we asked participants to listen to the pitch. And this is showing how the responses changed depending on the pitch cue level. You can see this function is very, very steep for Mandarin speakers, so they were very good at this. Their responses were almost entirely determined by what the pitch of the 2 words was. However, when we asked the participants from the 3 language groups to attend to the loudness, you can see that the Mandarin speakers were still affected by the pitch, even though this is a maladaptive strategy. So they had trouble ignoring pitch and attending to something else. So what this means is that when you first learn a second language, you start with the strategies you already learned from your first language. However, these strategies are pretty much always wrong to one degree or another for your second language. Now, eventually, as people live in a second language environment, their perceptual strategies will adapt to the second language. And we've run a follow-up experiment, again on Mandarin speakers, showing that after 10 years of immersion, their perceptual strategies do become indistinguishable from native speakers. So our hypothesis then for why we find this link between auditory processing and second language learning is that individuals with better auditory perception can more rapidly learn these new perceptual strategies, which are crucial when learning a second language. And we can test that moving forward by investigating the relationship between differences in auditory perception and how quickly these new strategies emerge. Now, finally, before I end, I want to address this second, more practical question of what happens if we try to train people's auditory perception. Will they then learn a second language faster? Now, a lot of prior literature in the auditory processing field has shown that auditory processing actually can be trained quite rapidly. Even in just a few hours, you can take one of these discrimination tests and people's thresholds will get much better. So that's what's being plotted here. This is just more or less a random example I picked from the literature. And each of these sessions on the x-axis only lasted about an hour. And you can see how rapidly people's auditory processing is changing. After about 4 hours, they become almost 3 times better than they were when they started. So this suggests that we can train people's auditory perception. And so we can do that and see what the consequences might be. So for example, what if we trained individuals to attend to a sound dimension we know will be important for their second language? Will they learn the best perceptual strategies more quickly? And will they acquire linguistic knowledge more quickly? So to put this more formally, our hypothesis is that auditory training will help people learn a second language faster, but only when they're immersed in a second language environment based on our prior findings. In other settings, like learning language in the classroom, there are other kinds of training that may be more effective, like working memory training. Before I end, I'd like to thank all the people who have helped me with this work. Obviously, Kazuya and I have been working together and done a lot of great things. In addition, my colleague Fred Dick has given me a lot of useful advice about a lot of these studies. And then as well, the many PhD members and postdocs who have actually done this research, including Mizun, Magdalena Kashlika, Katja Petrova, Kyle Jasmine, and Yui Suzuki.
Thank you. And so because of time difference, we're actually preparing this talk in advance. And I just want to add that we're presenting this talk from Adam's tranquil, gorgeous garden in London. Thank you, everyone.